There you go. This is a question to ask: what is the most beautiful feature in a programming language? Before I ask it, let me say, like with Python, I remember when I saw list comprehensions.
Okay.
It was like when I like really took it in.
Yeah.
I don't know. I just loved it. It was like fun to do. Like it was fun to do that kind of. Yeah, there was something about it to be able to filter through a list and to create a new list all in a single line was elegant. I could all get into my head,
Yep.
and it just made me fall in love with the language.
Yep.
So, is there? Let me ask you a question. Is there? What do you use the most beautiful feature in a programming languages that you've ever encountered in Swift, maybe, and then outside of Swift?
I think the thing that I like the most from a programming language. So I think the thing you have to think about with a programming language, again, what is the goal? You're trying to get people to get things done quickly. And so you need libraries, you need high quality libraries, and then you need a user base around them that can assemble them and do cool things with them, right? And so to me, the question is, what enables high quality libraries? Okay.
Yeah.
And there's a huge divide in the world between libraries who enable high quality libraries versus the ones that put special stuff in the language.
So programming languages that enable
High quality
high quality
libraries.
libraries. Got it.
And what I mean by that is expressive libraries that then feel like a natural integrated part of the language itself.
Mhm.
So an example of this in Swift is that int and float and also array and string, things like this. These are all part of the library. Like int is not hard coded into Swift. And so what that means is that because int is just a library thing defined in the standard library, along with strings and arrays and all the other things that come with the standard library. Well, hopefully you do like int, but any language features that you needed to define int, you can also use in your own types. So if you wanted to define a quaternion or something like this, right? Well, it doesn't come in the standard library. There's a very special set of people that care a lot about this, but those people are also important. It's not about classism, right? It's not about the people who care about ints and floats are more important than the people who care about quaternions. And so to me, the beautiful things about programming languages is when you allow those communities to build high quality libraries that feel native, that feel like they're built into the compiler without having to be.
What does it mean for the int to be part of not hard coded in?
Yeah.
So is it like how? So what is an int?
Okay. Int is just a integer. In this case, it's like a 64-bit integer or something like this.
But so like the 64-bit is hard coded or no?
No, none of that's hard coded. So int, if you go look at how it's implemented, it's just a struct in Swift. And so it's a struct, and then how do you add two structs? Well, you define plus. And so you can define plus on int. Well, you can define plus on your thing too. You can define int has like an is odd method or something like that on it. And so yeah, you can add methods onto things. Yeah.
So you can define operators, like how it behaves.
Yeah.
That to you is beautiful when there's something about the language which enables others to create libraries which are not hacky.
Yeah, they feel native. And so one of the best examples of this is Lisp, right? Because in Lisp, all the libraries are basically part of the language, right? You write term rewrite systems and things like this. And so
can you, as a counterexample, provide what makes it difficult to write a library that's native? Is it the Python C?
Well, so one example, I'll give you two examples. Java and C++, or Java and C, they both allow you to define your own types, but int is hard-coded in the language. Okay, well, why? Well, in Java, for example, coming back to this whole reference semantic, value semantic thing, int gets passed around by value.
Yeah,
but if you make like a pair or something like that, a complex number, right? It's a class in Java, and now it gets passed around by reference, by pointer, and so now you lose value semantics, right? You lost math. Okay, well, that's not great, right? If you can do something with int, why can't I do it with my type?
Yeah,
right. So that's the negative side of the thing I find beautiful is when you can solve that, when you can have full expressivity, where you as a user of the language have as much or almost as much power as the people who implemented all the standard built-in stuff, because what that enables is that enables truly beautiful libraries.
It's kind of weird because I've gotten used to that. That's one, I guess, other aspect of programming language design. You have to think, the old first principles thinking, like, why are we doing it this way?
Yeah.
By the way, I mean, I remember because I was thinking about the Walrus operator, and I'll ask you about it later, but it hit me that like the equal sign for assignment.
Yeah.
Like, why are we using the equal sign
It's
for
wrong.
assignment?
Yeah. And that's not the only solution, right? So if you look at Pascal, they use colon equals for assignment and equals for equality, and they use like less than greater than instead of the not equal thing.
Yeah.
Like there are other answers here.
So, but like, and yeah, like SQL, but how do you then decide to break convention, to say, you know what? This everybody's doing it wrong. We're gonna do it right.
Yeah. So it's like an ROI, like return on investment trade-off, right? So if you do something weird, let's just say like not like colon equal instead of equal for assignment, that would be weird with today's aesthetic, right? And so you'd say, cool, this is theoretically better, but is it better in which ways? Like, what do I get out of that? Do I define away a class of bugs? Well, one of the class of bugs that C has is that you can use like, if X equals without equals, if X equals Y.
Yeah.
Right. Well, turns out you can solve that problem in lots of ways. Clang, for example, GCC, all these compilers will detect that as a likely bug, produce a warning.
Do they?
Yeah.
I feel like they didn't. Or Clang does.
Didn't.
GCC didn't. And it's like one of the important things about programming language design is like you're literally creating suffering in the world. Okay. Like I feel like, I mean, one way to see it is the bicycle for the mind, but the other way is to like minimizing suffering.
Well, you have to decide if it's worth it, right? And so let's come back to that.
Okay.
But if you look at this, and again, this is where there's a lot of detail that goes into each of these things. Equal in C returns a value.
Yep.
That's messed up. That allows you to say X equals Y equals Z. Like that works in C.
Yeah. Is it messed up?
Well, so that
most people think it's messed up. I think
it is very by messed up. What I mean is it is very rarely used for good, and it's often used for bugs.
Yeah.
Right. And so
that's a good definition of messed up. Yeah.
You could use, it's in hindsight, this was not such a great idea. Right now, one of the things with Swift that is really powerful, and one of the reasons it's actually good versus it being full of good ideas, is that when we launched Swift 1, we announced that it was public, people could use it, people could build apps, but it was going to change and break. Okay. When Swift 2 came out, we said, hey, it's open source, and there's this open process which people can help evolve and direct the language. So the community at large, like Swift users, can now help shape the language as it is. And what happened is that as part of that process is a lot of really bad mistakes got taken out. Mm-hmm. So for example, Swift used to have the C style plus plus and minus minus operators. Like, what does it mean when you put it before versus after? Right. Well, that got cargo culted from C into Swift early on.
What's cargo culted?
Cargo culted means brought forward without really considering it.
Okay.
This is maybe not the most PC term, but
I have to look it up in Urban Dictionary. Yeah.
Yeah. So it got pulled. It got pulled into C it got pulled into Swift without very good consideration. And we went through this process, and one of the first things got ripped out was plus plus and minus minus because they lead to confusion. They have very little value over saying, X plus equals 1, and X plus equals 1 is way more clear. And so when you're optimizing for teachability and clarity and bugs and this multidimensional space that you're looking at, things like that really matter. And so being first principles on where you're coming from and what you're trying to achieve and being anchored on the objective is really important.